Hello everyone. Here I am Vadel Sagar. Let us discuss about standard number 12th and chapter number 1, electric charge and its field. I hope your NCRT textbook with you and whenever you see this video. Okay, it is starting with the introduction, and the second topic is electric charge. So as we discussed in our lectures, already we discussed about these things. As we discussed in our lectures, electric charge has two type: positive charge and negative charge, and then it's discovered by the Benjamin Franklin. Okay, there's a two way it will be react, either attracting in nature, either repulsive in nature. Two like charge, it means two similar charge, two positive, two negative charge are repel each other, and two unlike charge are attracting each other. This is a conclusion of it. Now how can you recognize, how can you judge the charge is there one device named as electroscope, that is also you should know before our discussion. After that, if you turn the page, then conductors and insulator comes into pictures. This topic is very well understood by the our students, already we discussed in our lectures. Charging by induction: if you rub any material, it has a charge, it has charge on surface. That process is named as electrified, and then transformations of charge by the one body to the another body, it's a charging by induction. That already we discussed. And after that, it is a basic properties of electric charge. Their first property is the additivity of charge. It means simply the total charge. If you want to find total charge, it's simply add. If I have a 5 positive charge, if I have a 2 negative charge, then the 5 minus 2, it means 3 positive charge I have. That is called simple addition of the charge for finding total charge. Then the charge conserved, it means the total number of charge in this universe is conserved. Whatever the positive charge, whatever the negative charge is same, so the total charge of the system is conserved, it is not, can be not change. Okay, then this third property is quantization of the charge. Please be with the textbook, so it will go with the flow. Quantizations of the charge: the quantization, it means the total charge of the system is always the integral multiplications of E, where our E is 1.60 into 10 to the power minus 19 Coulomb. Coulomb is the charge, or Coulomb is the SI unit of the charge. Okay, and anywhere you are finding the total charge of the system of the n time, it means n means it can be 1 2 3 4 any number. How many charge you have, that number is your n. Okay, the total charge should be integral multiplication of E. That is called quantization of the charge. Okay, okay, then if you turn the pages, that the right point what we discussed here, it is Coulomb's law. Coulomb's law is a quantitative statement about force between two point charge. Now first of all, what is point charge? Point charge means a charge whose size is very small compared to the distance between it. Here in the figure, the green one, the charge I am showing very large compared to its distance for our simplicity, but actually if you want to see, that charge should be very very small, as becomes electrons, protons, and like that, and they are separated by its by the very far distance, then this two charge is kept as a point charges. And what forces between it, that tells us by the Coulomb, that's named as Coulomb's law. Coulomb's measure the force between two point charge are found that the proportional to the charge q1 and q2. What charge it has? Q1, number 1, point charge number 1, and what charge point charge has? Q2, that is proportional. Somehow by mistakes is the question mark comes, it means it is a error by the ppt, not a problem with it. And we already discussed inversely proportional to the square of the distance between it. Okay, how far this 2 point charge it has, that inversely proportional of square. As you can see, the explanations, final explanations of the Coulomb force is F is equal to K Q1 Q2 upon R square, where Q1 is the charge of particle number 1, Q2 is the charge of particle number 2. As you can see in above diagram, you can take is a Q plus, Q minus, or the Q1 or Q2, and they are separated by the small distance r. That square is, you can see, and the denominator, it means your force should be reduces by the as the distance is increases, and force is increases as charge is increases. And this conclusion leads by the Coulomb by the many experiments, like he kept two charge at the specific distance between a specific distance far, and he performed, okay, he got a one force. After the completing the first task, he performed second. It means the distance between two charge is going to be doubled. Now r is going to be double, then he note the force is reduced. Then he decide, if r is increased, then the force is decreased, then it has a inverse relationship. So it is a inverse in that. And then also he found out is square time also inversely. And same task he did it for this distance is kept as it is, the charge what it has, it going to be double and half. He note especially, if your charge is increased, the force is increased. If your charge decrease, charge is decreased, force is decreased, then it's a proportional relationship, as you can see. And this all proportional relationship, if you replace by the some constant, here the k is your constant. The k is so far arbitrary, very constant, it should be positive number. The choice of k determine the size of the unit charge, and the SI unit of the k is 9 into 10 to the power 9 unit. I will discuss. You can also observe by the k as the main quantity, and others are also in the reverse side. That is, 1 coulomb is the charge. How the k is defined, let us see, very important part. That is, a 1 coulomb is the charge that when placed at the distance of 1 meter, 1 coulomb charge, 1 coulomb charge, these two 1 coulomb charge is r is the 1 meter from the another, then same magnitude, what magnitude of force they feel in a vacuum, the force is 9 into 10 to the power 9 Newton force. It means q1 q2 both are 1 meter, r is also 1, this all are going to be 1. Then f is going to be this k. Then they found out the f is equal to 9 in 10 9 into 10 to the power 9. So the k is also should be 9 into 10 to the power 9 Newton. Okay, this is very important. They may ask in examination how you can reach to the 9 into 10 to the power 9 answer of k arbitrary constant. Okay, the explanations, or somehow the question mark is here. Okay, if you are in a with your book, your k can be expanded as 1 upon 4 pi epsilon 0, where epsilon 0 is your permittivity of free space. Let me show you. Yes, so here the 1 upon second white frame, 1 upon 4 pi epsilon 0. Okay, that is a k. So this k, so the f is 1 upon 4 pi epsilon 0 q1 q2 upon r square can be. Okay, so where epsilon 0 is a permittivity of free space, what is the mean? Because if you want to just mug, okay, it is epsilon 0 is permittivity of the free space, but what exactly it is, the how much force is permit in space, it tells us by the epsilon 0, that is named as permittivity of free space. Okay, and its specific value is 8 into 10 to the power 8, 8.854 into 10 to the power minus 12 coulomb square Newton minus 1 meter minus 2. Okay, that specific value if you put at the 4 pi epsilon 0, 1 upon 4 pi epsilon 0, if you put, you will reach to your answer 9 into 10 to the power 9. So somehow invert both, vice versa, you can able to find it. Coulomb's law, a simple mathematical statement, was initially experimentally arrived at the manner described above. Was what I said, number of time experiment he did. While the original experiment established at the macroscopic scale, which is at the 2 point charge. It means two proton, two electron, proton electron, like it's far, it has a distance, its size is 10 to the power minus 10th order of meter. So think about it, it's a very small objects. Okay, up to this is the general form, but the force is a vector. So you should write your Coulomb's law, Coulomb's force law, in the form of vector. Okay, let us understand the figure. Here you can see the dots, two dots, which is a q1 and q2 charge. They are separated by the distance r21. Forget about it. See the point O. O point is your observation point. From the O point, the Q1 is far from the distance R1, as you can see. Then from the point O to Q2 is far from the R2. Okay, as we learn in 11th class, the vector sum is tail to tail joining, then the your resultant should be the sum or the subtractions of its. So here, that at the bottom of the bottom of this diagram, you can see r is the result of r1 and r2, then it is also denoted as a r21, kept it, then it should be subtractions of r2 minus r1. If it is r same, then r12 can be r1 minus r2, as we know. Then if you are just do some few steps of it, you will reach to the r12 is equal to r21. As you can see in a first equation, r2 minus r1, and second equation r1 minus r2, so it is a reverse, so it will be minus form of it. This is very important, please kept in your mind, it will help at the end of the result hour. Okay, so the force is the vector quantity. Let us do something. So here you can see on q1 charge, he represent one arrow towards the away from the q2, which is named as f12. What is f12? Force on q1 due to q2 is represented by f12. You should very clear about f12, f21. Okay, then f12 is force feel by q1 due to q2, and f21 is very well written here, or you can also see force on q2 due to q1 by f21. That is very clear frame. This slide is very important, please note somewhere. Okay, now for the up to this we are discussing about all about magnitude of its. In a vector we need two things, magnitude and direction. Up to this is f is equal to k q1 q2 upon r square. This is whole term is a magnitude. There nowhere we are discussing about what the directions of this force. What the force feel by the q1 is in which direction, upward, downward, left, right, so we are not bothering yet. So this is all about magnitude. Now we have to introduce the direction, and the direction is introduced using unit vector. The unit vector is a tells the directions of its. Now please be here, this is important and critical part of this discussion. The directions of vector is specified by the unit vector along the vector direction to denote the direction from 1 to 2 or 2 to 1. Now go back to the diagram. This the f12 is the having some specific direction. It is not upward, not downward, it has one specific direction. It is just like a towards the one away to 2. Away is there, q2 is away there, and q1 is here. Then it is a direction should be in specific. So it is represented by, okay, here is the r21. So let us understand r21. Here the force, it is f21, it's away from the q1 towards the q2 like structure. Okay, so the r21, it is a unit vector, is represented by vector r21. The bold is the vector. Okay, it has a arrow upward, you can draw in your textbook. So the unit vector r21 is tells us the directions of force f21, its vector, and denominated by its magnitude. So r12 is the same as, so the cap of r21 is equal to the r12, because the vector r21 and r12 is same. So very clear, this is about unit vector. So let us write the final form of vector form of Coulomb's law, F21. Which force? The force feel by the particle 2. Particle, it means charge 2 due to 1. 1 upon 4 pi epsilon 0 is nothing but the k, q1 q2 upon r square. Now it's modified in the way 1 upon 4 pi epsilon 0 is k, q1 q2 is the charges, and r replaces by r21 square. Now why r21? Because the force between 2 and 1 and towards the 2 due to 1, that's why we are using r21 distance, and r21 distance is a r2 minus r1. You can see the blue line. Okay, so the r21 square, and this is all about up to magnitude. Now we have to introduce the direction, then we have to use unit vector, and unit vector is r21 is as per our discussion, above discussion. Okay, now this is the final. The bold f is tells us it is a vector. The vector f21 is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r21 square into r unit vector 21. Okay, then if you same thing, if you write for the f12, the force feel by the particle number 1 due to 2 is same as k q1 q2 upon r square. Now it is a k will be 1 upon 4 pi epsilon 0 q1 q2 as it is, and r will be r12 square, and this is all about magnitude, and unit vector r12 is this. So as we seen here, r12 cap r12 is the minus of its. So if you put r12 specifically as a replaced by f21 is minus. Why? Because r12 is r2 minus r1, and r12, it should be r21 here. R above equation has r21 is equal to r2 minus r1, and r is equal to r12 is equal to r1 minus r2. So it is a opposite in nature. So if you replace f12 1 upon 4 pi epsilon 0 q1 q2 upon r12, unit vector r12 replaced by r21, then has introduction of the minus sign, and this leads the force, these two force f12 is exactly the minus of f21. What is it? Now please understand here, the force between two charges f12 and f21 is same in terms of magnitude, but in terms of direction is opposite, and this is very well understood by this diagram. You can see the directions of f12 and f21 is opposite, and this negative sign at the end tells us about this only. And another all terms